As infrastructure scales, running Ansible playbooks consistently across systems becomes more challenging. Playbooks are often executed manually or through custom workflows, leading to operational overhead and inconsistency. Progress Chef centralizes Ansible execution, enabling teams to run existing playbooks securely and repeatedly with better control and visibility. In this demonstration, Chef automates the enforcement of a firewall rule on an Ubuntu VM using an Ansible playbook. The goal is to block incoming traffic on port 8080. The playbook is executed by the Ansible Interpreter on the enrolled Ansible control node, which securely connects to the target system over SSH and applies the firewall configuration remotely. This lightweight approach reduces operational overhead, removes agent maintenance, and enables nodes to be onboarded quickly without requiring modifications to their runtime environment. Because execution is centralized and controlled over SSH, organizations can standardize automation, maintain security boundaries, and scale workflows across diverse infrastructure with minimal friction. Before creating the Ansible Interpreter, let's review the Ansible Interpreter documentation and the Chef 360 release notes. This helps confirm which skill versions are supported and ensures the interpreter is set up with the correct runtime. After confirming the supported versions, let's begin setting up the Ansible Interpreter in Chef 360. Under Node Management, select Skill Assembly. A skill assembly represents a reusable bundle of capabilities that defines what actions a node can perform, such as running interpreters or automation tools. Then, create a new assembly and give it a meaningful name, such as Ansible Interpreter. Next, add the required skills and save the configuration, which standardizes how Ansible will be delivered to nodes from this point forward. Next, move to Skill Definition and create a new skill. Provide the skill name, configure the canister details that contain the Ansible runtime, add any required dependencies, and save the definition. By doing this once, Chef gets a reusable version-controlled skill that can be applied to many machines without repeating the same configuration. After that, let's go to Settings and open Node Cohort. Create a new cohort, assign it a name, configure the override settings, and associate it with the skill assembly that was just created. Using cohorts ensures that every machine enrolled into this group consistently inherits the same Ansible execution capability, which becomes increasingly valuable as infrastructure grows. With the interpreter ready, a node can now be enrolled by providing its public IP, selecting the cohort, and supplying SSH credentials. After enrollment, the node ID is captured for job targeting. Next, let's move to the Courier Jobs interface. To streamline the setup, duplicate an existing job template. This allows us to reuse a known job structure while associating it with the Ansible interpreter we just configured. Then, assign our Ubuntu VM as the target node and review the node details to confirm that the job will execute on the correct machine. Before applying any configuration changes, switch to the browser to validate the current system state. The web page running on port 8080 loads successfully, confirming that the port is open and accessible. Now, look at the playbook itself. This YAML file includes the rule that blocks port 8080. And it's what Chef will execute through the Ansible Interpreter to update the firewall settings on our remote machine. Reviewing the playbook provides transparency into the exact configuration Courier will enforce, and shows how existing Ansible logic can be reused within Courier workflows. After reviewing the playbook, return to the Courier interface and execute the job. It uses the configured Ansible Interpreter to execute the playbook against the selected Ubuntu node. Once the job completes, return to the Courier to view the job success screen. Courier presents a clear summary of the execution, confirming that the firewall rule was applied successfully to the target node. Finally, return to the browser and refresh the web page on port 8080. This time, the page does not load, indicating that incoming traffic on port 8080 has been blocked. This before and after comparison clearly demonstrates how the Chef platform, through Courier, can automatically enforce firewall policies using Ansible playbooks. This workflow is not limited to a single firewall rule. It represents a repeatable automation model. Once the Ansible interpreter is configured, existing playbooks can be executed centrally through Chef without manually accessing each node. For more information, visit chef.io.